This tutorial is all about hydrocarbons and two kinds of hydrocarbons called alkanes and alkenes. You can recognize an alkane because it has only single carbon-carbon bonds in its structure. There are three kinds of structure drawn here. At the bottom is the ball and stick model that gives us an idea of what the molecule might look like in reality. The top left is the displayed formula. This one here shows you every atom and every bond, whereas at the top right we have the molecular formula. This merely tells us the number of atoms of each element in one molecule of the substance. That which is in yellow type shows the parts of the syllabus which are on foundation paper only. Those in white are on the foundation and higher level. So you're expected to know that hydrocarbons contain only carbon and hydrogen atoms, and you should be able to tell that from looking at a molecular or displayed formula of a hydrocarbon. You should also know that alkanes are one kind of hydrocarbon and that these contain only single covalent bonds between the carbon atoms. Although we don't cover bonding at this stage in the course, each carbon-hydrogen bond or each carbon-carbon bond is made up of a shared pair of electrons. You can see from this electronic diagram. Each of the carbon-hydrogen bonds is a shared pair of electrons, and these are called covalent bonds. Alkanes have only got single covalent bonds between the carbons and between the carbons and the hydrogens. Methane here is one example of an alkane. And here are some other examples of alkanes: ethane, propane and butane. Notice all of them end in ane, meaning that they are these alkane family, and all of them have only got single carbon-carbon bonds in their structure. Next we're going to learn about alkenes. These have got double covalent bonds between their carbon atoms. Again, there's a family of alkenes: ethene, propene and butene. It's worth noting then that this ending, in this case ene, tells us the type of compound we've got, whether it's an alkane or an alkene, whereas the first part of the name tells us something about the number of carbons. 1 carbon is meth, 2 is eth, 3 is prop and 4 is bute. So butene is an alkene with 4 carbons in it. Notice that there's a double bond between two of the carbon atoms. That's made up of 2 pairs of shared electrons. It's a double covalent bond. All alkenes have got at least one double covalent bond in their structure. Now some past paper questions. This question is about carbon compounds. Look at the displayed formulas. They are of propane, methanol, ethene, polychloroethene and carbon dioxide. Ethene is a hydrocarbon. Write down the names of the two elements present in a hydrocarbon. Well, we can see from that displayed formula there are only two kinds of element there, and they are carbon and hydrogen. Which compound is an alkane? Well, for an alkane we're looking at something which is a hydrocarbon, contains carbon and hydrogen only, so that means it's between propane and ethene. But here we can see that first of all the alkane would end in ane, and secondly it would only contain carbon-carbon single bonds, so the answer is propane. Which displayed formula contains only 3 carbon atoms? If we look at each, the first one appears to contain 3, the second one contains 1, the third one, although polymer, each repeating unit only contains 2, the fourth one contains 2, and the fifth one contains 1. Therefore the answer here is again propane. The molecular formula of ethene is C2H4. Write down the molecular formula of methanol. So we're looking at methanol. We're going to write down how many of each kind of atom there are. Well, it has 1 carbon atom, so we put an invisible 1 after that. It has in total 4 hydrogen atoms, so CH with a small 4 on the line or below the line, and 1 oxygen. Remember, we don't write 1s in formulas because the fact that we've written the element there shows that there must be one of them. Note in the answer scheme for that last question, there are lots of allowable answers because it doesn't really matter which order you write those elements in. Although this question is about polymers, we'll have a look at it anyway. Look at the structure of a new polymer. It is biodegradable. This polymer is not a hydrocarbon. Explain why. Well, when we look at the structure, a hydrocarbon would contain only carbon and hydrogen atoms, yet this one here also contains oxygen atoms. Therefore, it is not a hydrocarbon. It is not a hydrocarbon because its structure also contains oxygen atoms. Finally, look at the 5 formulae. Write down the formula that is a hydrocarbon. Again, we're looking for one that contains only carbon and hydrogen. At first sight, this one on the top right might appear to be, but look, here's a chlorine atom, so that one's no good. This one contains also calcium, this one contains also oxygen and sodium. This one has no carbon or hydrogen in, so the one we're looking for is this one. So we would copy down that formula for an answer, CC, H, 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 or we could write down its formula C2H6.